So if you plot out the expected value of the AC and the no AC option with the change the probability of the PE, we will obtain this graphical representation over here. Very important concept is that we call a treatment threshold or do not treat threshold. The treatment threshold is defined as the probability of the disease at which the expected values of the treatment and the no treatment are exactly equal, and neither option is clearly preferable. So the graphical illustration right here so that the treatment threshold is at the value of 0.032. At this point, two options AC and no AC have the same expected value of the outcome. Here we define the probability of the survival. We also see that if the probability of the PE increase right here, that's the value from 0 to 1, and it increased close to 1, the AC has much more benefit compared to the no AC scheme, and the net benefit compared to the two scheme defines the gap right here. On the other hand, if the probability of PE is small, less than 0.031, the no AC option is a better choice here because it has the higher probability of the survival here. We will discuss furthermore about the treatment threshold in the next few slides with the sensitivity analysis. So for analyzing the sensitivity of our decision, here we can discuss two main methods. The first one we call numerical analysis. So in this method, we carry out the analysis by constructing a decision tree and inserting the uncertainty as a variables. So particularly in our example right here, the disease probability, the probability of PE called PE. Based on this variable, we can calculate the probability of no PE. That's gonna 1 minus P of PE because the two events right here are complement. Similarly, we have the P of PE right here and 1 minus P of PE right here for the no AC option. So after that, we can either plot or tabulate the expected value for all the values this probability. So that means we're going to change the values of P of PE from 0 to 1, and then we're going to calculate what the expected value for this option right here versus this option right here. Microsoft Excel can be used for constructing the table. So here's the outcome of the table when you vary the values of PE from 0 to 0.1 with a step of 0.01. So you see the top value right here, that's going to be 0, and the last value right here 0.1. Just a small range, but you also can see the full range of the value from 0 to 1 as well. So from the table, you can see that the values of the AC and no AC in two different columns right here, changing corresponding to the value of the PP as well. So when P equals 0, the AC equals 0.992 and no AC equals 1. So this one, the optimal decision could be no AC because the expected value of this option higher than this one. Similarly, if you change the value right here, you can see the expected value of the AC changing and the expected value of the no AC changes as well. And for the smaller range, obviously no AC a better option. Now from 0.3 to 0.4, there's a change in terms of the expected value of the AC versus no AC. So at this point right here, at the value of P equals 0.04, the AC option have the higher expected value compared with the no AC, and the optimal decision gonna be changing as well. So you can see that by listing out the values of the PPE in a table and calculating the expected value of different options, we can determine our corresponding decision based on the value of PP as well. So that is the numerical analysis method.